Respected Madam Sir, this is Pavan Sai from CSC AIML from Section C. So today's topic is a class of invertible circular matrices for QC-LDPC codes. So why why do we study matrices in calculations? For the foundation of engineering discipline, crucial for problem solving in physics, computer science, and data analytics, applications in field like robotics, AI, fluid machines, and more. So, the concepts of matrices. A matrix is a rectangular array of number array in a row and a column, defined by order where we multiply rows and columns. The key operations, addition of subtractions, elements wise, multiplications, do not product or scalar multiplication, transpose, determine inverse essential, and the linear algebraic problems. So the applications, solving systems of linear equations like ax, capital Ax equals to small ax. So computer graphics, rotation, scaling, transforms, and the network theory of graphic representation, structure analysis in civil engineering. So concept of calculus, study of change and accumulation, two main branches, differential calculus and integral calculus. Where in differential calculus, it deals with rate of changes. They are also known as derivatives. In integral calculus, it deals with accumulation of areas under curves, integers. So the limits, foundation for derivative and integrals, where the application slope optimizes a problem. So let's get into the concept. So invertible circular matrices of QC and LDPC code. This presentation in this presentation we discuss about invertible circular matrices for consumption power and efficient QC-LDPC codes, emphasizing the matrix mathematical properties and applications. So we deal with error corrections, lower density parity, and excellent performance. In the correction, the QC-LDPC codes are a class of error coding by using in a communication and storage system. Low density parity check. They are characterized by their sparse parity check matrices leading to efficient decoding algorithms. Excellent performance. QC-LDPC codes offers exponential performance in terms of correction and capability of a code. Overview of circular matrices, the structure, and the properties and applications. These three are the main keys which depends. So the structures. Circular matrices are square matrices where each row is circle shifted and in a previous row with the properties. They process various properties that simplifies their manipulation and analysis. Applications. Circular matrices are widely used in signal processing, code theory, and other fields. The properties of invertible circular matrices. Determinant, equivalent, inverse. The determinant of an invertible circular matrix can be computed using its first row, and the equivalent of invertible circular matrices are closely related to the Fourier transformation of the first row. The invertible and uh, of an invertible circular matrix is also a circular matrix, simplifying the compensation. In the interconnection between matrices and calculus, matrices and calculus together in engineering are three methods: Jacobian matrices, differential equations, and eigenvalues and eigenvectors. So the practical examples, real world problem, using of matrices to solve a system of an equation, applications of calculus for optimizing and minimum cost efficiency and maximum cost efficiency, maximizing the efficiency also. So the conclusion, Summarizing the importance of matrices and calculus, the backbones of advantageous engineering and technology, highlighting the relevances to solve real-world problems and advantageous innovations. Preparations, uh, including visual aids, by using real-world examples. They are relative to your audience's engineering specializations, allows for times for questions and encourage discussion of an application. So the constructions of the invertible circular matrices. So choosing the first row starts by choosing the first row of the matrix, ensuring it's meet certain conditions. Second one, the shift and fill generates subsequent rows by cylindrical shifting the first row to the right, and the vertible check verifying the results of the circular matrix in invertible, guaranteeing its suitability for the code structure. As we can see, there's an example of the matrix constructions of invertible circular matrix at the left side. The algebraic structure and complexity analyzing properties, algebraic structures, description. Invertible circular matrices from a group under matrices multiplications, and the complexity of an analysis. This complexity of construction, the inverting circular matrices is relevantly. And also, a matrix is a structure arranged of numbers in rows and columns used to represent linear systems of transformations. This algebraic structures analysis shows the results and the operations. We can additionally multiply, add, or subtract the transpose determinant and inverse. Matrix multiplications convert linear transformations, where we can learn differential calculus, where we can concerned with instantaneous rate of changes, derivatives, applications optimize maximizing profits and or minimizing costs of motion, velocity, acceleration. Efficiency in engineering, we use these tools to solve real world problems faster and more accurately. And the scalability, many real world systems can be understood by scaling linear and non-linear equations foundations. So we got three real world examples like bridge design, robotics, signal processing, and the foundation in which foundation is for modern innovation, which is related to core to AI, robotics, civil, and physics engineering. So we're going to the next slide. So encoding and decoding with invertible circular matrices. Encoding. Encoding involves in multiplying the message vectors with the circular matrices, efficient generation the code. And decoding. Decoding utilizes the algorithm to decode the received code efficiently, correcting errors including during transmissions. Um, Encoding is and decoding is also very secure process. While we are sending a while we are sending a file, we encode it and the receiver decodes it, which is very secure, where others cannot see without the passcode of the program we set. And the performance analysis of QC-LDPC codes. There are two types of performance: block length and SNR performance. The block length QC-LDPC codes demonstrates excellent error corrections and the capability of particular for long block lengths. In the SNR performance, the code exhibits the good performance, even ratios, making the robust in the noisy environment. Applications and benefits of invertible circular matrices. Satellite communications QC-LDPC codes ensure reliable data transmission in challenge space environment. Data storage. This enhance data reliability and integrity in source storage devices, preventing valuable information. In the wireless networks, QC-LDPC codes improve communication quality efficiently in the wired networks. As we can see, there is an example, three examples. One is investigating Q cells, LDPC, and applications of LDPC codes by investigating the calculus and matrices. And the last slide, the conclusion and future directions. There are two conclusions. One is efficient codes and future researches. These are the main parts of this whole PPT. So first one, efficient code invertible circular circulant matrix provides a powerful tool for constructing high performance QC-LDPC codes. And the future researches, further researchers focusing on exploring new constructions and optimizing performance of these codes. Hope you like my presentations and thank you.